founder of the Department of Computer Science at Tallinn University of Technology and has been director of the department over than 16 years. Currently, he is a professor of computer science at the Department of Software Science, Tallinn University of Technology. He has been visiting professor at Abu Academy University at Final, visiting researcher at also Oslo University, Norway, Danish Technical University, Tampere University of Technology, Final, and Eindhoven University of Technology, the Netherlands. His current research robotics and artificial intelligence. He has been leading researcher for PhD students have graduated under his more than 150 international conference, summer and winter. Professor Yuri to present his.
And I return back to the title. This talk is about aspect-oriented modeling. And more specifically, it's about the advantages of using aspect-oriented modeling in verification and testing. How many of you are working with formal methods? If not, please don't be scared about the title, Upal-Timed Automata. I will not go into very details in here, but try to convey the idea of aspect-oriented modeling and verification. So these topics are all studied in the context of software assurance. And what is those who don't? Here is a short definition which says that it is a set of methods and technologies to achieve required level of confidence. And this concerns software functional correctness, freedom from vulnerabilities, security capabilities, and resilience, which means systems should be able to recover from intrusion and failures. We have many examples from bad assurance. Fiat recalled back more than 16,000 vehicles because of software bugs. The control system suddenly shut down the engine and the driver couldn't do anything. So this sort of bug was designed in the software. Same happened with Ford. About 500 million of cars were recalled due to the bug where the driver switched off the engine, but the engine didn't stop, so it's opposite. And I think that many of you have seen the video in Google where hacker is standing next to the road, having a laptop, and then stopping the Chrysler cars which are passing by. So Chrysler had problem with security, and via entertainment system it was possible to hack into the system and take over the car control. So the statistics says that about 15% of software bugs, they are built into the systems when the cars are manufactured, and this is huge amount of money actually to call back the cars and repair these bugs. And this is only in the field of car industry. One may ask, these are very smart people who are programming cars and such kind of very obvious bugs in there. And actually there is a long list of reasons. Maybe most important ones are shown in here. First, the complexity of software. And this complexity comes from the hardware-software co-design. So there are different teams, different development cultures which have to be integrated into one product. Heterogeneity of components. These components in hardware, in software, in mechatronics, they use very different technologies, and the final product is mix of them. Variety of scales. We can have nanoscale technology there, chips, sensors, and these cars can communicate over autonomous navigation and control systems. Timing requirements. There we have hard real-time requirements, weak software real-time requirements, and these are also put together in the product. And maybe finally the most important is not only the multiplicity of different aspects, but the possibility of interference between these different aspects. And that makes this design extremely complicated, and in these days there are many ways to overcome these, but time will show how efficient are they. In the first place, there are so-called quality assurance processes and standards which tell how to organize these manufacturing processes, testing, how to do the code checks. And the second is also rising trend. This is a so-called provably correct software development. This includes formal methods and model-based testing. Those people who are working with formal methods, they know already a long time that formal methods, they are promising, they allow to prove correctness, so we get provably correct products, but there are some shortages. And main problem is low comprehension. It means the engineers who are not aware of the details of formal methods, they find it very, very annoying to read these formal specifications. And on the second hand, there is a problem of limited scalability. Formal methods work well with small systems for small models, but they usually don't scale well with large systems. But there is still common belief in the community that modularization methods, abstraction and slicing principles allow to structure the specifications and models so that these verification techniques, they can be applied. And this study in here is also focusing on one of the structurization method, which is maybe less touched than the component-based approaches, but this is orthogonal to these. And this is called aspect-oriented modeling. We study aspect-oriented modeling in the context of Hubbard-timed automata. This is a formalism to model timed systems and verify using model checking. And based on this model checking, witness traces, the tests can be generated. So this is also basis for model-based testing. These two, verification and model-based testing, can be considered in one context. And the goal of this study is to evaluate aspect-oriented modeling and verification techniques based on Hubbard-timed automata to answer two questions. First, are models easier to construct and update using aspect orientation? And second, is a compositional verification and test generation from those models possible? If yes, what gain they to provide? Can we reduce the complexity or somehow divide and conquer the problem, so to say? Before getting to the analysis, a few definitions and introduction to aspect orientation. Programmers probably know Java programmers that there is a so-called aspect J Java extension which allows to describe the aspect-oriented constructs. Now this was extended to a wider methodology, so-called aspect-oriented software design development, and the advantages or benefits of this have been pointed by Stutton already in 2006, and there are following advantages. First, separation of concerns. So the problem was developers' comprehension when they are working with models or specifications. And development in these semi-formal methods, they will give some advantage. Ease of maintenance, evolution, and customization, also related issues. Greater flexibility in development, so the principles of modularity allow to localize the updates and have better view. So why this is orthogonal to component-based methods? It's because if component methods, they structure the according to the units of code, then aspect orientation is dealing with cross-cutting concerns. And there are two effects related to cross-cutting concerns. First, scattering. It means specifications related to one concern are distributed over several code units, over several components, so to say. And tangling, this is opposite. A given unit contains specifications related to several concerns. And these issues are not addressed in component-based methods. And the core principle is here that the aspects are developed independently at first, and then via so-called weaving process, they are put together or composed to get a full product. Now, aspect-oriented modeling is a bit younger field of research, and this is based on the ideas of aspect-oriented development, which are combined with formal and model-based methods. So the main question is here: how to structure the concerns and how to put them together later on, how to compose them. The mechanisms are important here. And there are two papers by Ali and co-authors who have studied these techniques based on UML models, and they have shown that these models also give better quality and improved readability, but they haven't studied how it influences verification effort, which is very important in these critical applications. And our study is focusing more on verification and test generation. So what are the main principles of aspect-oriented modeling? Here we have base model, so to say, which describes the basic behavior of the system on abstract level. And then the concerns, they are expressed in so-called advice models. These can be parallel compositions of automata, if we talk about UPAL-timed automata, and to compose these different models, aspect models, base models, we need so-called join points in the base models, the points where these two models interact. Here they are depicted as dots at the boxes. And now when these aspect models, they are executed, there is one entry and multiple exit points when the controller is returned to the base model. And for each aspect and for each join point, we have unique instant of advice. This is called the concern. And to avoid race conditions when we weave the models, race for aspect models, each of these join point has its own instance of the aspect model or advice model, and the execution of these advices is atomic, so it doesn't interleave with the rest of the base model executions. Okay, now the main question is how to construct these compositions and how to define the weaving mechanism between the base and advice models. And this is called weaving process, where we can apply certain model patterns. They are called weaving patterns. To be more formal, we'll introduce now these UPAL timed automata models. These are state machines, extended state machines, where we have clocks to model timing constraints. The model is parallel composition of processes, where each process is described by model template. And template consists of locations and edges between locations. So locations model states and edges transitions between these states. But these are not states in traditional sense, because during the state or location, when the controller is in one location, then time is progressing. Since clocks are our representatives of time in the model, so the state actually is also the value of clocks, but since the clocks have infinite, they are of type real, they have infinite domains, then we describe this using invariants. So whenever the execution is in one location, it should satisfy the invariant of this location. For example, here the clock X should be less or equal to 3 or 5. And there are also transition guards conditions which are defined on clocks, and synchronization conditions if we compose in parallel different automata, their transitions are synchronized, and resets of clocks. On edges, we can reset the clocks or compute some functions in UPAL models which are defined on state variables. Now, coming back to the composition weaving patterns in timed automata, we need to define the constructs to show how the aspect models, they have containers which allow to compose with a base model. In here, this container is shown outside of this ellipse. This is advice model, and it has container which defines how this is activated and how it returns control to the base model. And we call it adapter, weaving adapter, and this weaving adapter actually is split into two parts. One is in the base model side and the other in the advice model side. From aspect J, we know there are weaving operators before, after, around, and these can be easily represented also in timed automata. Taking transition as a join point, which has its own guard condition, it has update, it has synchronization. Now this before is represented here as adapter before this join point transition. Around, this is before and after is after the edge, which defines the join point where these models can be woven. In addition to those, we also defined so-called additional conditional adapters, which allow to activate the advice model under certain conditions, and for iteration as well, the last one in here. Now, the goal of this study is to compare non-aspect-oriented and aspect-oriented models. For this, we have used several case studies. One is in here. This is called the Crisis Management System, defined by Kiesler and colleagues in 2010. And this provides a nice right-size example to evaluate the efficiency of aspect orientation. The scenario is following. Here we have coordinator and resource. Coordinator is coordinating the mission. When the call comes in, there are witnesses where there is some accident, for example, a forest fire, and the coordinator estimates the type of crisis and allocates certain number of resources to fight the fire. Here we have three procedures. First, resource allocation. Since this is a critical mission, we have to authenticate the resources to send right or not to spread information anywhere, and execution of the critical mission by resource. First, we construct the flat model. It's non-aspect oriented model where we have coordinator functioning behavior shown. Coordinator will start the mission, and this C system automaton in here takes care of allocating the resources. Resources are feasible if they can estimate the time, how long it takes to reach the crisis region. If it's not reachable within given time, then it refuses for the mission, and the other resource has to be allocated. And when the resources finish the mission, then they synchronize or send back the signal that is mission completed, and it should be done within mission time, which is necessary to be followed. Functionally, same behavior has been represented also in aspect-oriented model, where we have aspects in the boxes here. This is about authentication function, and the other is another aspect is mission execution by a resource. The base model in here for the resource is shown up the upper box. Now, having non-aspect-oriented and aspect-oriented models, we have to be sure that these two models are representing same behavior. They must be behaviorally equivalent. And for this, we use pi-simulation relation to prove that these are really behaving same way, these two models. And to prove pi-simulation, there is easy way to construct the automaton or composition of automata and apply deadlock checks using model checking. And the steps are following. First, we compose non-aspect-oriented and aspect-oriented models in parallel. Define the observable interface. This is relative by simulation relative to the I/O actions, and add then side effect-free synchronization constraints between these two models. So when one model is doing this I/O action, the other one is synchronized with as well. And then we run a deadlock detection model checking query, and if there is no deadlocks, then these two models are bisimilar. So the first research question was about modeling effort, and our experiments show that we started this study with authentication aspect. We modified this in both models, and initial model was very simple, where we had just resource credentials and mission system checked if these are correct credentials. Bisimulation was checked between these models, and the models were updated with Needham-Schroeder protocol, the models shown above. And again, the models were checked for bisimilarity. The results show that in the flat model, this update took about 40% of model size. It was measured in terms of state additions and updates and removals, and the same in aspect-oriented model took about half of it, so it was much easier to modify. And this is because of the locality of the scope in aspects, so they are well modularized, so and it's much easier to comprehend these pieces of model. Next, this is evaluation effort of the verification effort, and verification was done using safety property, which says that in all computations of the model and in all states, if the deadlock occurs, it implies that the system either has completed the mission or there is a timeout. So timeout means that it hasn't been completed within expected time. And the table below shows that actually a flat model took more than 100 milliseconds to prove this property. In aspect models, base model with authentication is half of it, and base model execution aspect took very little, just 5 milliseconds. But of course, there is a number of stored states which is greater, and this is because of adapters. So adapters bring in extra structural complexity, which indirectly also influences the results of model checking complexity. So based on these experiments, we can draw some conclusions, and first of all, these aspect-oriented concepts in formal modeling, they allow to improve the expressiveness of the models, give the better understanding of functions. We have also built a tool which assists in automation of the weaving process. And the experiments, what we did, show that both human comprehension and the verification complexity get better from this. The drawback is, of course, the structural complexity, where the adapters will introduce extra model fragments, but this is not critical, since this doesn't influence actually the interleaving between parallel automata in the composition. Future work. We want to focus on aspect-oriented testing, in particular use the aspect-oriented structures to define test coverage criteria. So relating these coverage criteria with constructs of aspect-oriented models, and see what is the effect. Can we somehow prove the effects of interference between different aspects? and how this influences the scalability of models, because the fragments of models or aspect models which can be verified separately, they depend whether they are interfering with each other or not. So we cannot actually separate the aspects which are interfering strongly. Then we get just wrong results. And also how to build feasible increments of aspect-oriented test suites in regression testing. So this is shortly what I wanted to present. Thank you.
Thank you. Any questions?
Thank you, Professor Yuri, for your presentation. Just I want to ask about maintainability and sustainability.
Yes, the effort that we is in regression testing, we can reuse the old parts of the model. And whenever there is a new increment in the software, it's much easier to add certain aspect model to the old one and build up the models incrementally and use the advantages of these compositionality, what does it provide.
Maybe here it will increase the complexity of the aspect, no?
Yeah, complexity is one of the most critical aspects in here, because model checking and algorithmic verification techniques, they suffer from the scalability usually.
Thank you very much.
Thank you.
Our chair for our speaker.
Thank you.
Thank you. Thank you so much for the Ictus Day 3. Our second session today is on the topic of prospects and opportunity with IEEE. And we are very thankful that today we have with us Vice Chair IEEE UAE Section, Dr. Fatima. Before I invite our speaker, let me introduce the chair of this session. The chair for this session is with us, Dr. Ajay Rana. To introduce Dr. Ajay Rana, Dr. Ajay Rana is spearheading variety of tasks at Amity University, India. Some of the key areas what we can mention here: advisor to Amity Alumni Association, founder director of Amity Strongest Corporate Department, which is ATPC, very popularly known back to Amity Noida. Founding director for the unique concept Amity University Summer School, leading the association of 9 campuses of Amity University with association with MHRD for the admission with the help of JEE over the 6 years in a row. Additionally, he is also the part of Amity Academic as well as Executive Council. Dr. Ajay Rana have a very rich experience of the industry and the academia over more than 20 years. His tenure at the Amity has led to an overall excellence in education, research, infrastructure, and systematic development of the organization. His current focus is to enhance the quality of education with the help of strategic quality initiative. Dr. Ajay Rana has visited many top universities, to name only few of them: University of West England, University of Nottingham, University of Wales. The list is very long. Some of the very key contribution, which is Amazon mobile application, Amity radio channel, Amity central library, we can program, digital library. These are the very few what I can take as a name. The list is actually very long, which is with me, and it is not only the list. I personally got a chance to work with the Dr. Ajarana. Please, sir.
Thank you, Dr. Shukla. So it's our honor in our Dubai campus, we have the eminent personality. So it is my duty to introduce my colleague on the very innovative topic, that is prospective and opportunities with IEEE, not in the UAE but across the globe. So Dr. Fatima Tahir is working in the College of Technology and Innovation at Zayed University, Dubai. Her research interests in the area of signal and the image processing, medical image analysis, especially in detecting the cancerous cells, multimedia, watermarking detection, pattern recognition, remote sensing and satellite image. She received her PhD in Khalifa University of Science, Technology and Research, UAE in 2014. So that she is the first UAE local and the graduate with a PhD in engineering inside the UAE, and Khalifa University considered as the first university to grant PhD degree in computer science engineering. Dr. Fatima has published more than 30 papers in international journals and conferences of repute. She served as a member of the technical program community and the many international conferences such as IEEE ICECS 2013, ICT IST 2011. Dr. Fatima is the Vice Chair of IEEE UAE section, and that is a great contribution for this conference as well, Ictus 2017. I request you give a huge round of applause for Dr. Fatima. And important thing is that beside the chair of this UAE section, Vice Chair of the UAE section, as well as the Chair of Education Committee in the BCS Society in UAE, Dr. Fatima has received many distinguished awards, such as prize of the Best PhD Excellence Award in the Leadership Day of Khalifa University, 12th of February 2012. Best Paper Award in the BCS International Conference towards 21st Century Innovation, Abu Dhabi, UAE, 31st March to 1st of April 2013. Best Paper Award in the first prize in the PhD Forum of the 20th IEEE International Conference on ICECS PhD Forum, December 8 to 11, 2013. And recently, there's a new milestone. She was awarded the UAE Pioneer Award in the first UAE create a computer-aided diagnosis system for the early lung cancer detection based on the spectrum color image analysis, awarded by His Highness Sheikh Mohammed bin Rashid Al Maktoum, 15th of November 2015. In addition to that, she was awarded an Innovation Award at 2016 Emirate Women's Award by His Highness Sheikh Ahmed bin Sheikh Al Maktoum, Chair of Civil Aviation, Authority and Pattern of the Dubai Quality Group. So the entire list is going on. Without wasting my time, I request you, our honorable speaker, Dr. Fatima Tahir, to present the presentation. Ma'am, please.
Thank you.
No.
Like this? Okay, update. Hi everyone, thank you for introducing me. This is Dr. Fatma, the Vice Chair of IEEE UAE section. I am the acting chair in IEEE UAE section. I will talk about the IEEE, and I'm sure that you have some idea about it. but I will explore more on how you can benefit from it and how maybe you can join it in the near future. So our mission is advanced technological innovation and excellence for the benefit of humanity. So IEEE stands for an Institute of Electronic and Electrical Engineers in the worldwide. It is a worldwide organization, and we have in UAE part of this big organization. So it is not necessary to be an engineer. Any scientist, any students that's in the under the umbrella of IT and engineers, all they can join us. So it is the world's largest technical professional organization dedicated to advancing technology for the human, for the benefit of humanity. So it is established in UAE. It is established in 1987 as part of Region 8 of the mother organization IEEE. So the main branch in USA. Then we have many branches. It's coming in the next slide, will be clear for you. So our vision is to advance global prosperity for fostering technological innovation, enabling member career and promoting community worldwide. So here we are in the blue area, Region 8. It's composed of many regions, Middle East, Africa, Asia. All this, we call it Europe. All this, we call it Middle East. Then you have, actually it's 10 regions worldwide. You have 1 to 6 US. Then you have the rest in Canada and Brazilian and the Asia. All this, the biggest one is Region 8. So here in UAE, we have many members, fellow, senior member, associate member, affiliate, then graduate group member and student member. For a student member, it's very cheap, maybe $25 per year. For the regular member, $120 per year, but you will benefit a lot out of this. And here, it's a great opportunity for all the students to join IEEE because it will increase your profile and will give you a value in your CV. When you will write you are an IEEE member. Imagine you join now and after maybe 10 years you will become senior member. Also for the faculty who completed 5 years and more in PhD, they got their PhD and they join any university with assistant professor. Then if they completed 5 years, they can become a senior member. And this is benefit for them to join IEEE. So abroad there in US and Europe, all students, they are curious and passionate to join the IEEE because they know the IEEE will help them to find their next job career. So our objective is to promote the spirit of volunteerism in the UAE society, engage young engineers and scientists in the practical activity and strengthen the concept of the nation. So how we impact IEEE drive the technology that improves the quality of life. IEEE student membership, serving and preparing our next generation for leader. So we have many branches in UAE, especially for students, and we are working to have a 1 branch per university in the UAE. So engage students in the mission, benefit and opportunities of the IEEE. This is our goal. And sponsor activity and event, technical, professional and humanitarian aspiration. So if you join the IEEE for the student, maybe you will be a part of a competition. And that competition, for example, I will give you example and do an اتصالات. If you win, for example, the first prize, or immediately do or اتصالات, they will register your name and they will keep a track about your record. Then maybe they will sponsor you. So you will get a sponsorship, then immediately you will get your job because you were a member in IEEE and you participate in their concept. So many companies, especially in industrial across the year, they establish a competition between the university joining and targeting the IEEE member, student member. So if you are a member, you will receive email from this company asking you if you are interested to join their competition. Then in the competition, you can recognize yourself there to them. Also, you can learn in networking, how you can network with people in this competition. Not only you will learn how to do a network, a connection, how to meet a leadership and managers people, the people who is the stakeholder in this country. Another and most important thing, you can find your job career there in this competition, especially as I said, if you win. So if you win any competition, then it will be easy for you to get your next career. So you can be also, you will learn, you will meet many guest speakers, you will participate in paper contest, local public improvement. Then as I told you, you will have a lot of fun, social event, you will meet other students across the UAE. So here in UAE, we have 28 student branches across all universities. We have almost in all Emirates, starting from Abu Dhabi to Al Ain, Qirwain, all the Emirates, we cover all. We have a branch in each one. And in some cities like Dubai, we have almost in all universities. So this is, I have some example for you. For example, in each year, there is something we call it IEEE UAE Student Day. And this is Student Day, there are many competitions that we announced it earlier in our year. So a student can participate. For example, we have senior design project. If you have a project in your university, so you can, in your final year, you can participate with that project. Maybe you will win. So it's a competition between all the student IEEE members across the universities, and it's a good opportunity to meet your competitor from other universities. So this was an example, 2016. It's held in Al Ain University of Science and Technology. Attendance was 264 students with 60 student teams, a competition, 5 technical and 1 committee. There will be a technical committee composed of an instructor across also different universities, and they are all IEEE member. So the next year, it was held in 2017 in Khalifa University. And in this year, in the coming year, 2018, it will be in April in Dubai University next to you. So it will be a great opportunity for you to participate. So as I said, there will be a lot of teams, a lot of concept to participate, senior design, robot, programming concept, a lot of it. You can visit the website to explore more. So this is some images. Then we have IEEE UAE Student Day. Here in this slide, I hope it's clear. You can see all participants from what's the categories. We have different categories, different universities, different team. The university can participate with more than one team, not necessarily with one team, in different categories. Then if we have a winner, then we can take them in the Middle East. We have a GCC conference. This is the Student Congress held in 2017, last year in May, in Bahrain. So we took the winner team, sponsored them to participate again and competitors with the GCC's country. Then we have this team from Ajman University. They participated with different projects. This is an example of their project, VR-based cruises training system. Then this is the annual general meeting. We invite all IEEE members, students, and faculty to attend once a year the general meeting, or we celebrate the year with all our members. So this is Dr. Isa Bastaki. He's the founder and honorary chair for IEEE. He was the chair for 15 years. And he's the one who established the IEEE UAE section. This year I attend the Region 8 meeting. We have, in a year, 2 times we met. This is in GCC Conference again. We have also for ladies, if they would like to join, IEEE Women in Engineering Society, where a lot of benefit for women, and there is a lot of summit held during the year. So in the UAE, we have 11 society chapters, 3 joint and 8 chapters. And if you are a faculty and you are interested to establish new chapter, we are willing to help you. So we have Communication Society, Signal Processing Society, and you can see the number of members, and actually it's growing. Each year it's growing. The UAE is very active section across the GCC and Middle East. And the members are going to increase in each year, especially for the student. Okay, you can see here all the different society with different members, and in each society we have chair, vice chair, treasurer, and okay, we have these members, and you can feel free to join anyone that meet your research area of interest. We have a report for 2016 event. Actually, we keep tracking of all the society, their activity. Sometime we invite a lot of keynote speaker, and we invite all the members to attend this session, and it will be great benefit for the students to meet a different keynote. So we keep a track of all society if they have activities, technical session, workshop, conferences, and we encourage them and sponsor them. Society chapter chair, here the name of the chapter's chair in different society, and we assigned them to be a chair for 2 years. Then after 2 years, we have another election to change them and give the opportunity to other people. So in conferences, IEEE in UAE section sponsor many conferences, technical sponsor, so that this conference can publish the work in IEEE Xplore. So our conferences are increasing in the last 5 years, and we during 2016 and 17 we host many conferences like Third Smart Cloud Network System, International Conference in Electronic Device System and Application, as you see, and it's going to increase. And in 2018, next year in December, we are going to host GlobeCom, one of the flagship conference worldwide, and this is the first time it will go out the US to attend to be in Abu Dhabi. We expected attendees around 2,000 people, and this is rank A conference. So also ICIP, in 2020, this is the first time it will come to Middle East in UAE in Abu Dhabi, and this is a very large conference, rank A flagship conference. The expected attendees will be around 2,000 people. So IEEE publication advanced author idea by publishing research for delivery to key technical audience. IEEE Xplore, a well-known place where all scientists people can publish their work, and it's a well-indexed, well-known publication. So here leads as the most cited publisher in the new patent for the top patent organization, and it's, as I said, it's a well-known cited over 3 and more often than other publisher. And usually most people looking, if your conference proceeding will be published in IEEE, then this gives a higher priority for your conference to be registered by the authors and different scientist people. So it is a very well-known place that people like to publish. So the intellectual property or research in one place, it's guaranteed that your research will be unique and will be published in a safer place. So then it is an open access. Now almost 99% of the universities, they have a free access to IEEE library. So all students can download different research articles from the IEEE. So authorship behind technology are researchers who choose to publish with IEEE and contribute to IEEE conference. So benefiting the global society, IEEE touch everyone in their everyday lives because technological touch everyone. So IEEE enable the human desire to achieve, to learn, to know more, and to help others. Its education program provide opportunity for lifelong continuous education. Collaboration is our foundation. You can teach you how to collaborate, how to do a network, how to connect with other people in your field. So the IEEE, you have an academic and industry in different fields, and collaboration will open the opportunity for most people. So together we engineer a bright future, and thank you for your attention.
We have any questions here? Yeah.
Okay, thank you for giving such a wonderful talk regarding the IEEE. I want to know, I'm also the secretary of IEEE Uttar Pradesh section, which consisting the geographical boundary of Uttar Pradesh, Uttarakhand and Nepal. So I want to know how many student branches you are going to have, because I know that Amity University is also having, Dubai is also having the student branch. What kind of activities you are organizing just about your UAE section?
You want to know the student branch across UAE, or where you want?
Under UAE section actually.
Here I display this one. So here we have the student 800 in 2016, and I didn't receive the latest in 2017 and the celebration. So and that's report for 2017. But as per my knowledge, it's increased. 11 maybe, 11 or no, we have 28 student branch. Yeah, okay. We have 28 student branch.
Very nice, very nice. Thank you.
And the society, I think.
Thank you.
Yeah.
Presentation, in the slide, you mentioned about technical, non-technical events. So whatever non-technical
yeah.
events that you have sponsored,
We sponsor most of them technically, because when we sponsor technically, IEEE, for example, this GlobeCom, the Society of Communication, and we will get a benefit 20% from that conference. So this 20%, for example, 1,100. So because we expect that this conference will be success. Definitely, because it's a global conference. So next time, the Society of Communication has in their budget 100,000 dirham, they can sponsor another. So they can get benefit of that money. So in this way, we sponsor non-technical. Okay.
Thank you so much. Thank you so much, ma'am. We are very honored to have you here today for the keynote speaker. Can I request the chair of the session, Dr. Ajay Rana, to step forward to present a memento to our vice chair, IEEE, for this keynote talk. Once again, thank you so much, ma'am, for being here. Ictus, day 3, we have the last session for the today. And the topic for the last session is data-driven decision making. For this session, we have Chair Dr. Piyush Maheshwari, and we have a speaker, Professor Mario Jose Dewan. Before I request the speaker to step forward for the presentation, let me introduce the chair for this session. The chair for this session, Dr. Piyush Maheshwari, he is currently heading the Department of Engineering and Architecture at Amity University, Dubai. Dr. Piyush is recognized technology leader, educationist, and computer science researcher. He has earned his PhD in the computer science from the University of Manchester, UK. He is a very senior member of Institute of Electrical and Electronics Engineering, IEEE, at the Computer Society. With an overall experience of 30 years in the ICT industry and CSE academia, Dr. Piyush brings with himself distinguished and well-recognized thought leadership in the areas of enterprise and solution architect, cloud, and SOA-based software system integration, mobile-enabled application. He has co-authored 100+ papers in the various technical journals and international conferences. He has been a keynote speaker into the various international forums such as NGTC 2016, ICE CCS 2016, Middleware 2010, AU S Grid 06. He has served as a program committees of the leading conferences reviewed by many technical articles and examined over PhD thesis. Dr. Pius has also contributed his services to the leading organizations such as IBM and Siemens. Software architecture. Please welcome Dr. Pius. Thank you so much, sir.
Thank you, Dr. Vinod. So we have honor to have another keynote speaker, Dr. Mario Divan, for this session. I would read and it's my pleasure to read the biography of Dr. Mario Divan, who was born in March 10, 1979 in Santa Rosa, which is in La Pampa, Argentina. He's married with Maria Laura, and he has 2 sons. He is full professor and head of the data science group at National University of La Pampa, Argentina. Dr. Mario is honorary professor of the Amity Institute of Information Technology in Noida from 2016. He is system analyst in 2002, information systems engineer, specialist in managerial engineering, and MBA from National Technological University in Cordoba, Argentina. Dr. Mario is specialist in data mining and knowledge discovery in databases from the University of Buenos Aires in 2007. Dr. Divan is specialist in high performance and grid computing from University of La Plata in 2011. He received his PhD degree in computer science from the University of La Plata in 2011. His scientific research interest lies in the area of data mining, data stream mining, high performance computing, big data, measurement and evaluation. Dr. Divan integrates the academic committee for the master and the PhD in computer science at the National Technology University in Argentina from 2012 to 16. He's the director at the Professional Council of Engineers and Technicians of La Pampa. In 2012 and 2015, he has been recognized by the Argentinian Computing Society with the National Award of Electronic Government. In 2016 and 17, he received the Best Paper Award in Data Analytics track in the International Conference on Reliability, Infocom Technologies and Optimization, which is ICRITO. In the private sector, he has worked from 2002 as consultant in decision support system for different industries, such as the pharmaceutical, government, elementary, beverages, construction, oil, and many others. So yeah, let's welcome Dr. Divan for giving a beautiful talk. Yeah.
Thank you, Professor, for your nice introduction. Let me check the introduction. Okay, good morning. Our presentation today is about the data-driven decision making. Our roadmap I would like to talk about a brief introduction related to data-driven decision-making, briefly about measurement and evaluation, the social impact of the data-driven decision-making, show you an application case, and finally the related works and some conclusions. Okay. When we have the decision-making process, we have internal and external factors. The internal and external factors interact every time, and from that interaction we get a feedback. This feedback allows us fit our behavior, and in the internal factor we have premises and knowledge of our company, our own data. In the external factors, we have the context and some assumptions, but the context and the assumptions is out of our control. In this sense, we need information, and data and information should be differentiated because data and information are very different things. If we have some value and we store that value, we have just data, some value in a persistent repository. But the information is that data that simultaneously satisfies 4 characteristics. The data is consistent, it is current and cohesive, the data is traceable and current, and the data it is available in the right time. The 4 characteristics is very important that will be satisfied at the same time. In this sense, we have the information systems. Inside the information system, we can model the information system through the business processes, and the business processes give us many data, but not all the data is information. Just the information will be the data that satisfies the consistency, the traceability, the currently, and the available in the right time. In terms of measurement and evaluation, we can try each process such as our entity under analysis. So the first thing is identify our entity under analysis. In this case, for example, we can use each business process as entity under analysis, and from each entity under analysis, we get data and information. But the measurement helps us for knowing a characteristic related to an entity under analysis. Why? Attributes. The attributes could be physical or logical characteristics that allow us to describe the entity. But for quantify the behavior of each entity, we use metric associated with an attribute. In this sense, the entity, in terms of the business process, could be described through any quantity of attribute that allow us to describe the process and their behavior. So, in this sense, the measurement helps us for knowing a characteristic related to an entity under analysis. For example, the lead time in a business process. The measurement process the measurement process is a key asset because it should be repeatable and the results consistent, traceable, and comparable. Because if I have a value today and I will have a new value tomorrow, I suppose that the two values are comparable for knowing if I'm going in the right way. Okay, in terms of the measurement and evaluation, we use the CINCAMI framework. CINCAMI is an acronym of Context, Information Need, Concept, Model, Attribute, Metric, and Indicators. CINCAMI has an associated approach called GoCame. GoCam is acronym of Goal-Oriented Context-Aware Measurement and Evaluation that could be synthesized as follows. Firstly, we define the information need, for example, to monitor. Secondly, we identify the entity under analysis, for example, a business process. Next, we describe the entity's characteristics through their attributes. For example, each characteristic associated with a process, a particular process, each attribute will have an associated metric for its quantification. But the metric gives us a value, not the meaning of the value. So we have indicator for interpreting the metric's value, incorporating the decision criteria. Here is the business knowledge. What is the meaning of 4? What is the meaning of 5? Yeah? The metric should give us the number, not the interpretation of the number. It's a big difference. In this sense, what is the usefulness of the measurement and evaluation framework in this sense? We can get an automated measurement and evaluation process, and we can use an organizational memory. If we can get an automated measurement and evaluation process based, for example, in this case in Sincami, we can get previous experience from my company and store in a repository for supporting future decisions, future recommendations. In this sense, we use an organizational memory, and on the other hand, we can feed many common boards from the real-time processing associated with the business processes, each business processes. The idea, in terms of data-driven decision-making, in terms of Provost and Fawcett, is the data-driven decision-making is the practice of basing decisions on the analysis of the data rather than purely intuition. So, we use the previous experience in the organizational memory, the knowledge in real time through the common board for making decisions. The organizational memory gives us the recommendations from the previous experiences. In terms, for example, the smart cities, we can define the smart cities in terms of Sutherland and Koch, such as cities which integrates and monitors the critical infrastructure using smart computing to deliver core services to public. In this term, the measurement and evaluation process is critical. For what? However, what if we don't have the data? In this case, we take the risks. If we don't know the situation, if we don't have data, if we don't have information, just we take the risk. For example, Argentina is located in the South America, La Pampa is located in the middle of South America, and here we have the city of Santa Rosa. In the city of Santa Rosa, we have a lagoon called Don Tomás. It's a nice place. We can play football, walking. We can do many social activities. But this year happened this. In this case, the intuition-driven decision-making, because we don't have data, we don't have previous experiences, we don't quantify the behavior of the lagoon, for example, and the full absence of automated measurement on the lagoon, such as such entity under analysis, no presence of automated evaluation or real-time monitoring. The overflow of the lagoon affected the basic services of the whole city. The sanitary networks are collapsed. The action plan will demand at least 5 years of continuous public works for solve at least a partial situation. As you can see, all this region is part of the city, but the region is under the water. On the other hand, for example, in this application case, we work around the autarkic Institute of Housing of La Pampa between 2014 and 2015. This institute is a provincial public organism. It's responsible for the building of houses along all provincial territory. The future owners of each house are associated with families without the enough resources for accessing to the formal system carried on the banks. Thus, the associated demand is continuous, and the offer is always lesser than the demand. So, the critical point is that we need to identify to each family and monitor the demand, and we need to make the distribution of the houses between the most needy families. Our work strategy as follows. We identify the main processes into the information system, and from each processes we take 3 perspectives: a business perspective, a functional perspective, and technological perspective. The business perspective was driven by metrics, because we need to make decisions, but the decisions should have data as foundation. So each process was characterized by attributes. Each attribute was quantified by metrics that say us the quantitative behavior associated with this indicator from the value of the metric associated with the attribute of the processes. So the metrics and indicators allow us feed a new common. On the other hand, the processes was derived through use cases. From use cases, we can make different user interface prototypes and to build a navigational map prototype for the perspective functional. But in the perspective technological, we used REST web service for make interoperable all this information with another public organism. As you can see, the demand of the housing is growing permanently. For example, this number are each 2 months between 2014 and 2015, and is permanently growing, except in this situation when the distribution of housing was made. Okay, there are some works about, related to the Harden and others that they propose an idea related to obtain requirements from business process. We share that idea, and additionally our proposal includes the idea associated with measurement and evaluation process as monitoring, because our final idea is guide the process through the information-driven decision-making, not data-driven decision-making, because we need consistency, traceability, and comparability at the moment in which we need use the data for making decisions. Cullari and others proposed the idea related to incorporate the simulation for avoiding the human dependencies in the data-driven decision-making. That is an interesting point. In this sense, we incorporate the organizational memory for storing the previous experiences and for supporting future recommendations at the moment that we need to make decisions. As conclusions, we use the measurement and evaluation as base of the data-driven decision making because we believe that we need an information-driven decision making. And in this sense, the measurement and evaluation frameworks as base for the automatization of the measurement and evaluation process because we need a measurement and evaluation process repeatable with results comparable. The business process or the city's infrastructure could be considered as entity under monitoring. Even the systems, software, components could be considered entity under monitoring. Finally, we can see through the pictures, we can choose in the information-driven decision making for keep this picture, or we can use the intuition-driven decision making and we take the risk. Yes?
Any questions? Yes.
You mentioned indicators and attributes and metrics. Could you mention some of them? First question. Some of the metrics and indicators you used in that case. And the second question, have you considered using satellite mapping in order to derive some time series rain for the lake case?
The last, please, again.
You can use satellite imagery from the past in order to derive height of the lake. It has happened in Cordoba, and it has been done because we did the same mistake in Cordoba that you did in La Pampa. So we didn't have any data. I didn't do it, but I know it has been done. You can use satellite imagery to derive the height of the lake and get some resemblance of data from the past to predict future levels.
Yeah. Okay. In the first place, in relation with your first question, the metric and indicators are defined in terms of your necessity, your information need. For that reason, when we introduced GoCame here in the presentation, the start point is the information need. What do you need? From that information need, you will choose the entity under analysis. And from that entity under analysis, you characterize that through the attributes. Each attribute depends of you the way in which you want quantify. You can define the metric. The importance of the definition of the metric is key because you need to make comparable the results. So in the metric, for example, you will define the scale, the units, the mechanism for getting the value. So we can reuse the previous definition of the metrics along another projects, not just in this project. And in terms of this, remember the second question, please?
Using imagery to derive the lake height.
Drive?
Derive the lake height, the height of the water in the lake.
Okay. Really we can, in this case, sadly in this case, I think that with using very cheap sensor, that situation could be avoided. Because a simple Raspberry Pi with, yeah, 20 or 30 sensors give us alarms about the situation. But in this situation, there not exist nothing, really nothing. So avoid this situation is very easy. So we need a little quantity of heterogeneous sensors even. So we need get the data from that sensors and interpret in real time and make decisions, and civil defense could be advised about this situation for make some decision and avoiding those, all these consequences. Welcome.
Any other questions? Thank you so much. Thank you so much.
Thank you.
May I request Dr. Professor you, sir, to step forward to present a thanks memento. May I request Dr. Dilip Sharma also please to join us for the group photograph. May I request please all of you to please join us for a group photograph. Thank you for participating on Ictus. Thank you for all the time for the 3 days. After this group photograph, we are moving for the lunch. Lunch is placed on first floor, student lounge area. Please join us for the group photograph. Dr. Munir, Dr. Lakshmi, Murtaja, sir, please. Thank you all. We can move forward for the lunch, first floor. Thank you so much.